In today's video, we're going to build our jump state, as well as improve our fall state so that we can handle things like variable height jumps, different jump speeds when you're running versus walking, and even adding Coyote Time so that there's a little bit of grace period for your players when they're playing your game. Hey, Michael here. Throw on your favorite game dev tunes and join me as we build a 2D platformer in Godot 4 using GD script. All right, so welcome back. I'm finally feeling a little bit better, though you can still hear a little bit of the cold in my voice, but it's been a doozy, I tell you what, a couple weeks. Let's look at the project here. Where we left off, we added the run with this little skid animation and with some variable speed. And the fall state that we have in our game already kind of works, at least for the purposes of what we have so far. And what we're going to build today is our jump state, and we're also going to kind of augment or improve our fall state to include more features like the Coyote Time, which for those of you who don't know what Coyote Time is, you have to think back to old Wile E. Coyote cartoons where he would run off of a cliff and it would take a second before he realized he needed to fall. We're not going to make it so that there's a delay with the fall, but that there is a grace period where the player can press jump and it'll still jump, even if you just barely walked off an edge. And we'll discuss a little bit why I've chosen to separate these states like I have, and hopefully have some fun learning along the way. All right, so first let's go ahead and go into our idle state, and let's just hook up our jump state from the idle state so that we can kind of start testing it out from there. And I'm going to go ahead and start removing too some of these print messages from these states that I don't think we need too much anymore. But what we're going to do is come down to handle input. And I realized as I was sitting down to record this that the way I wrote some of my code in the run state in our last video, we're going to adjust slightly. And you'll notice a difference in how we're going to use our handle input here. And what we're going to do is we're just going to check this event, right? We've got this event that we pass in, which is an input event. And we can just do dot and this is action pressed, right? And so the action we're looking for obviously is jump. So there we go. We'll just check if the action pressed is jump. Now the thing that's kind of different here, I'm gonna go ahead and return the jump state actually. Okay. But the thing that's different here is, let's go ahead and just open the run script. In the run script, we did this input.action is just pressed, meaning was it just pressed that frame? Now, the reason why we're going to change this is I don't know if there's actually much of a drawback to this. This is perfectly valid, but this is just taking the event that's already passed through the handle input. So we know that it just was pressed this frame, or it is being pressed. But obviously, if we're going to be handling this and returning the state, then we know we're only ever going to handle it once, right? So this is just the way that maybe we should write the code. Again, there's maybe not a whole lot of drawback to the other way we did it, but you know, maybe I'll learn a little bit more and I'll have a different answer for you in the future, but this is how I want to do it moving forward, okay? So we'll just take this input event and we'll handle that. There is another key difference. The input event does not have an is action just pressed. You can see we've got is action pressed and is action released, but we don't have that is action just pressed, which is visible on that global input class, okay? So anyways, going back here, if we save our game and just run this, we should see that we switch to the jump state when we press our jump button. So I'm going to press it. You can see we entered the jump state. Okay, so that's working. We're going to go ahead and copy this code. And then we'll go ahead and put it in our run state as well. I'm going to put it down here after these checks. And we can make this an elif. And I want to go ahead and change these. I'm just going to change this to underscore event, and then we'll change it to is action released, and this will be is action pressed, and we'll change this to underscore event. That way we're checking the same thing throughout our code and it's consistent. Now, using that other input syntax is very useful outside of the handle input because obviously we're passing the event in here, but a good example is here in our enter we have this input.isActionPressed. This enter state doesn't have any knowledge of an input event. And so that's why we're checking the input class directly to see if the action is pressed. Okay, so there is obvious uses for this. I just don't think it's quite necessary within the handle input function. All right, so there we go. Now we should be able to jump while we're running, but it's not going to do anything. It's just going to lock us into that jump state, which does nothing yet. So let's go ahead and start working on the jump state. All right, so let's dive into the jump state. So I'm going to go ahead and open this script here. And obviously we have kind of a blank slate, and we know that we can enter the jump state, so that's good. I'm going to go ahead and delete that. And I'm going to delete the exit as well. Okay. So let's start though by setting up some of the variables that we're going to need in this function. Oh, and real quick, let's remove this or comment out the init. We're not going to need that. But let's go ahead and begin adding the variables that we want in our jump state. So a couple of the things that we want to do is we're going to want some variables that will allow us to control kind of how high we jump, or maybe the velocity is what I'm going to use as the approach I will take. We'll also need an audio file to play when we jump. And I'm going to add in as well some move speed and acceleration values so that we have separate in-air movement from our run movement. Okay, so we're going to control that separately here. And so we'll add these variables, and then we're going to slowly begin to implement and refine the jump state from there. Okay, so first let's create an export variable, and this will be our jump velocity. This will be of type float. And I'm going to set it equal to 350. And then we'll export a jump audio file. Type audio stream. We don't need to initialize it with a value. And then we'll export our base move speed. And I'm going to just go ahead and go over to run. And I'm going to copy this, probably these two values here. We'll just base it off of these. Similar names anyways. So we'll have I'm going to call this base move speed, and you'll see why, because we're going to alter this, and I'm going to set this to 100. So it's kind of like our regular move speed. And then we need an acceleration, which I'm going to default to 8. That was the acceleration we used when we were in our skid. And I don't want the movement in the air to feel too floaty or soft. And so again, obviously you could increase this or decrease it as you see fit for your game, but 8 is going to be a pretty comfortable value. And then I'm going to have one more variable that's not exported, and it'll just be called the move speed. And this will be of type float. And I'm not going to initialize it with a value either. Okay, just leave it as is. So there we go. These are the variables that we're going to need. Once we save this, then we can come and look at our jump state node and just adjust some of the settings here. I'm going to go ahead and load a jump audio. And we have a jump audio just right here. Let's go ahead and preview it. Okay. Hope that's not too loud. It's pretty kind of loud to me, but I think it should be decreased slightly in the recording. So there we go. We've got our nice Marlowe jump sound effect. So we can go ahead now and begin set up our enter function as well, because here we'll just kind of initialize all of the things that we need to on our player, right? So we're going to, like our other states, we'll grab our animation player and just play the correct animation. And then the other things that we need to do here are we need to begin to manipulate our player's rigid body, or the character body, okay? So one thing we'll do is I'm going to increase the position by -1, moving it up 1 pixel. This way, I don't know that this is completely necessary. I've kind of always done this as a habit. It's helped avoid some collision or, is on floor versus is in air kind of comparisons. So if we instantly just make sure he's 1 pixel off the ground, then that'll kind of help make sure that there's no confusion there. So I'm going to say player dot global position dot y minus equals 1. Okay, so we're just going to move it up 1 pixel. And then we can also set our player's velocity. And I'm going to go ahead and just type this in here. So we're just going to set the y velocity. So player.velocity.y equals, and it's going to be negative the jump velocity. Okay, so this variable up here that we're going to set, it's negative because, again, negative is kind of the up direction, right, in our Godot 2D game. So we want the negative of the jump velocity. And we can also go ahead and play our audio. So I'm going to say player. If you recall, we made this play audio function. So we'll call this, and we'll just pass in our jump audio. And let's go ahead and just run this and see what happens. So from an idle state, I'm going to press jump. And wouldn't you know, it jumped. Obviously, we don't have a condition to leave the jump state, so he's kind of stuck. And we haven't done a whole lot, but that's nice that it worked that well with so little code, right? Now, we will be making this a little bit more, complicated, but just to refine the feel of this jump. But there's basically what we need. So let's go ahead and maybe provide a condition for the player to leave the jump state, and then this will help us have a little bit more of a testable feature. So down here in our physics process, we can just do some checks. And what we'll say is if player.isOnFloor, right? We use that previously when we were testing, then we know we can return the idle state. And because we have a unique fall state, I also want to hook that into this. And so let's handle that here as well. We can say elif player.velocity is greater than or equal to 0. So once the player, or you could maybe just say greater than, but either or. So once the player's velocity is no longer a negative number, it begins to be positive. That's when he starts to go down. So then we can return the fall state. Okay. Apparently I've got a little, this should be velocity.y. That's why that's given us a red highlight there, because we're only checking the y velocity for this. Okay, so that's a way for us to get from idle to fall. Now, you may think that this is hardly necessary because we've got this condition to return to the fall state, and the fall state should get back to the idle state. But I'm going to leave it just in case there's a possibility that the player somehow lands on something before his velocity really changes, which, I don't know, might be possible. So let's go ahead and test this one more time. There we go. So now he jumps and falls. And if we're moving when we jump, then he keeps that velocity, right? But it's pretty static right now. And if I'm not moving and I'm hitting arrow keys, he doesn't begin moving left or right until he lands. Okay. So we're going to deal with that. And again, like I said, refine kind of how this works and how this feels. All right. So let's go ahead and address being able to move while you're in the air. And we're going to have to handle this both in our jump as well as in our fall state. So let's just come in here. And this is going to be pretty simple. We have this player.update velocity, or not, yeah, update velocity function that we created so that we have a consistent way to update the velocity with an acceleration. And so all we really need to do here is pass in our direction, direction.x multiplied by our move speed, and then also include the acceleration. Okay. So just by adding that line of code, now we can move while we're, oh, that's not working. Let's go ahead and stop. What did I do? I must have done something wrong here. Oh, I see what I did wrong. We're adding our move speed, but remember how we have this base move speed and move speed. This is not initialized, so it's set to 0. Okay, so let's talk about why. And to start, let's just go ahead and set our move speed equal to the base move speed, which seems stupid, but it's because we're not going to keep it this way for very long, okay? So now, there we go. Now I can press a direction. Even if I'm idle and I jump and then push a direction, he'll move, and I can kind of change direction in air ever so slightly. If we were to increase that acceleration rate to a very high number, then he would be able to, you know, turn on a dime, as they say. All right. And I'm not super happy with the jump height because I can't quite make it on top of that. So maybe we increase this jump velocity just a tiny bit. So maybe something like, I don't know, let's try 400. And if we want to change that acceleration, we could try something like 20. And now you can see I have a lot more maneuverability in the air. Okay. And I can jump up pretty high. You know, I can get from here to here. Okay. So that's working a little bit better. But the reason why I want to do this move speed separate, let's dig into this real quick. What I want is I want the movement speed that we're using when we begin to actually be equal to whatever it was when we were running. Because right now we're setting like a generic move speed on our jump. But if we look at our run script, we actually have the ability to be holding down, you know, a modifier and run faster. And I want to be able to inherit that in my jump. Okay. So we're going to use this to do that. And here's how we'll do it. We'll first start by changing this line of code. And we're going to use a little simple function that's called max. And we have to wrap this in some parentheses. And what max does, if we look at it, is it's going to pick the highest of two numeric value, or multiple numeric values, I guess. I was saying 2, but as you see here, it can take any number of arguments. Okay. So what we'll do is let's go back to jump, and it probably should be max f because these are floats, right? So what we want to do is we want to get the maximum between our base movement speed or how fast we're running. In other words, what this is going to do is if we're running really slow and we jump, then it's just going to say use movement speed of 100. But if If we're sprinting and we've got that movement speed of 150, then we want to use that as our movement speed instead of 100, okay? Or if we're at 125 or whatever the case may be. So what we'll do is we'll provide the base move speed as one value, and then we will also provide, and we want to do an absolute value here, right, of our player's velocity, and just the x magnitude or value. And so what this is going to do is say, well, how fast are we actually running? And if you notice, if we're running left, we'll get a negative value, which would turn out to be smaller. And so we would get the base move speed. That's why we're doing the absolute value, so that we can just get the magnitude, not the, without positive or negative. Okay. And so there we go. We've now got a way to dynamically set our move speed. And let's go ahead and just test that out, see how it feels. And actually, before I test it, let me do one thing. Let me come over to my run speed, and I'm going to set this regular speed to 50 and the sprint speed to 200, so that there's a noticeable difference when we're testing here. Okay, so if I'm running and I jump, you can see the move speed is going to 100 because that's the base. But now if I'm sprinting and I'm going even faster, then you can see I can jump further, right? And let's find a good spot to test this. I think there's a good flat area down here. Maybe not. I don't know. Okay, what we'll do is we'll run slowly off the side here and jump. Boink. We landed somewhere right about here, right? So now let's sprint and run. Boom. Very different. And so that's just the difference there, where we're inheriting our movement speed at the time that we jump. And if needed, we want to have a minimum of that. Okay, so there we go. We've got a slightly dynamic feel to our jump. But there is one thing, and actually I should run again. Let's just look at this. Right now, there's no variable height. Our jump height is always the same. I can tap it, and it does full height. If I press and hold it, it does full height. And I want a jump that feels more dynamic than that. So we'll handle that next. So in order to make this jump a variable height, the method that I'm going to employ is quite simple. And we're going to go into our handle input here, and we're going to say if event.isActionReleased. And if it's the jump, if they release the jump button, then we want to do something different, right? And the first thing we could do is we could return fall, the fall state. The problem with this is we not only need to return the fall state, but we need to modify the jump. We need to kind of cut it off. And so what I'm going to do is I'm going to, rather than do a hard set, well, in fact, actually, let's try that. Let's just say player.velocity, if I could type it, .y equals 0. And if we try this, you can see if I let go of the jump button midway through, he starts to fall. But it's pretty abrupt feeling, though, in that situation. Doesn't feel great. So instead of just setting it to 0, let's say multiply equals 0.5. So now we're just going to cut it in half. So whatever it is, it's going to reduce by half. Now if we run this, now you can see that even when I let go early, it kind of still has a little bit of a smooth fall off, right? But it can terminate early. So I can do a tap jump for a short jump or press and hold for a high jump. Now, one thing that we haven't dealt with that we need to fix now is that our fall state doesn't have some of the same functionality as our jump state. And I think a common way most people would handle this is they would want to do the fall and the jump all in one state. And I don't necessarily have a problem with that, but I see some benefits to doing the fall state separate. And so we're going to now move to the fall state and improve that. And if you decide you want to try and merge your fall and jump state into one, then by all means, go ahead and do that. Okay, so jumping over to the fall state now. What we need in our fall state, we're going to need some similar variables that we have in our jump state. And so this is why it might feel kind of redundant, but I'm going to go ahead and just actually copy all these over, and then we can weed out the ones that we don't need. So let's see, jump velocity, I guess, and jump audio, maybe we don't need those, but we can keep the base move speed, the acceleration, and even this move speed variable. Now, what I also want to add to this, though, is I want to export a variable for our Coyote timer. So we'll call this variable Coyote Time, which is a funny name, but once you learn it, you kind of stick with it. I don't know. You're welcome to call it whatever you want, but I think Coyote Time means something. 0.125. If you don't know what Coyote Time means, then maybe you need to look up Wile E. Coyote. Okay, so we have our Coyote Time. It's going to be a small amount of time. And well, it'll be an export variable, so we can play around with it and change it. And then I'm also going to create another variable in here that we just call our Coyote Timer. It'll also be a float, and we'll just set it up just like that. I'm going to comment out my init. You're going to notice we don't use the init function a lot. Some of the stuff that I built into this tutorial series are forward thinking, and they may not be necessary for this series or even for you in your game, but they're things that I added with more fuller feature set in mind. And so if we don't use them here, just know that these are hooks that are useful for the future. The init is one of those that I don't believe I'm going to use that in this 8-video series, but I intend to add features in the future where I do intend to hook into the init and use other things. So just kind of a little note. You might think like, why is he doing this and not using it? That seems stupid. And yeah, you might be right, but also I think it's there for some sort of purpose. So, okay, let's go ahead and clean up this fall state a little bit and get rid of our prints that we don't need anymore because we know it's working. And we are already playing our fall animation. That's good. We'll go ahead and keep that there. And now what we want to do is we want to set our movement speed just like we were in our jump. So we'll say, in fact, maybe we just copy this line a little bit. So we've got a move speed here. Copy that and paste it. So our move speed will be the same thing, right? It'll be the maximum, either our base move speed or our current. So that this way, if you're running off a ledge, we'll still get that same movement speed dynamic adjustment. If you're sprinting, you'll still fall further when you run off a ledge than if you are not sprinting. And then I want to go ahead and instantiate my Coyote Timer. So we'll set this up here, and then we'll kind of deal with this in the next step. But our Coyote Timer should equal the Coyote time, like that. And then there's an if. If our previous state was jumping, we've already jumped. That means we want to ignore the Coyote Timer. So we'll just say if, and this is where the previous state for our state machine will come into play. We'll say state machine dot previous state equals jump. Okay. Then we're like, well, actually, we don't want Coyote Time, because you'll see what Coyote Time will do is it allow us to jump again, like I mentioned earlier, even after we've maybe run off a ledge for a split second. So we'll just say Coyote Timer equals 0. We don't want to do that. Otherwise, we'll unintentionally create a potential for a double jump, but it won't be a proper double jump. It'll just be a buggy double jump. We don't really want that. Okay, so if you wanted to double jump, we'd build that into our jump state and into our fall state. So now we've pretty much set this up. We're going to come back and add one additional thing here in a little bit, but that's looking pretty good. Let's go down to our physics process, however, and let's finish hooking up the velocity. So right now we can say player.update velocity, and it'll be just the same as what we were doing in our jump state, right? Let's see, what did we put in here? Direction times move speed and acceleration. Okay, so I'm going to copy those values, paste it in here, and there we go. So now we've got this updating our velocity. So we should be able to see that our player moves in the fall state similar to how he moved in the jump state. All right. And looking pretty good. Now, one thing I want to do to spice up the fall state, and this is kind of borrowed directly from some Nintendo franchise of note, but in order to make the jump feel a little bit more dynamic, I want Marlowe to fall a little bit more quickly when I want the gravity to be more intense when he's falling than when he's going up. And it's just going to add a dynamic feel. And we'll make this an export variable as well so that we can allow you to maybe play around with it. So let's go ahead and I'm going to export another variable up here at the top. And we'll call this variable the fall gravity. Oh man, you guys, I cannot type. Thankfully, you're not here for a demonstration on typing. Okay, so this will be a float, and I'm going to go ahead and set it equal to 1.165. And I need an equal sign to do that. Okay, so we're going to have this fall gravity. And before we can really use this, though, we have to come into our player. Because remember, we're actually applying the gravity here in our physics process, right, in the player script. And so we need to kind of have a way to tie this all together. And what I'm going to do is I'm going to scroll up here. We have a gravity value. And you know what? This is funny. This is one thing I added in the first episode or two that we just don't need. That move speed was there for demonstration purposes. And I ended up hard coding that 100. We're going to delete that. Okay, but underneath gravity, I want another variable just like that fall gravity multiplier that we have in our fall state. I want a gravity multiplier in here. And by default, it's just going to equal 1 because we just want normal gravity. And then what we can do is we can come down to our physics process. And here where we're increasing our velocity by the gravity, multiplied by the delta, we can also multiply this one more time by the gravity multiplier, okay? So this will allow us to pass in a custom value and change the gravity on the player during any given state. This would be useful if you wanted to make a float state, then you could set the gravity multiplier to like 0.5 or 0.25, and the player would begin to fall very slowly while they're in that state, right? For a regular fall state, we're going to increase the gravity ever so slightly. And in order to do that, what we need to do is in our enter function, we'll just grab our player dot gravity multiplier and set it equal to our fall gravity multiplier, just like that. Now, because we're adjusting the gravity here, whenever we exit the fall state, we want to reset it back to 1. So we can just go to our exit and say player dot gravity multiplier equals 1. Now, this should give us a slight different feel. I'm going to go ahead and run the game. And it's actually kind of imperceptible, but he falls a little bit quicker. If we wanted to come over here to our fall state and really crank this up, and we could maybe change it to 3, then this will be pretty obvious, I think. Woo, yeah. He suddenly falls like a brick. Okay, so 3 is way too much. You can play with that a little bit if you want. This value is based off of some people who've done research, and they think that this is like, how Nintendo does it. So, have fun with that. Just a little extra little tidbit, a little bit of spice you can add in there to make your controller feel a little bit different. You can add, make it floaty, make it less floaty. You could even go into your jump state and add a similar functionality into the jump state where your gravity multiplier is less than 1, or, do whatever you want. Have fun and play around with it. Okay, now it is time for the Coyote Time, right? We've kind of set that up. We've got our variables for a Coyote Time in here. We even instantiate in fact, I'm going to move this down. Wasn't paying attention where I put these lines of code. I want those Coyote Timer bits of code next to each other. Okay, so we set up our Coyote Timer here, but we're not doing anything with it throughout the rest of the state. And so let's finish the Coyote Timer and demonstrate how it works. And I should note, the reason why I like the fall state separate is because having this Coyote Timer only happen on the fall state makes it easy to implement it without, in my opinion, overcomplicating the script. So even though we've got some redundant repeated code in this when compared to the jump state, personally for me, I like the segregation of duties that it gives me for the code. And to some degree, this is a personal call. Okay, this is just me giving an example of how I like to build my platformer controls. So do what you want. Now, and actually, I should say, if I were doing an advanced tutorial, we could make states that both inherit a state. And so we could actually build all the common code for the fall and jump into one state that's called like a player in air state. And then we could make our fall and our jump both extend that in air state and add their unique functionality as needed. That would be a cool exercise, something that I don't intend to do in this video. Okay, looking at the fall, let's do this. Enough of me rambling. So first we need to update and handle our Coyote Timer, right? And so I'm just going to come to my physics process and go Coyote Timer minus equals delta. Okay, so that's just going to decrease that value by however much time has happened during the frames. Then what we can do is we can come up to our handle input. And obviously, in fact, let's just go ahead and demonstrate what happens without the Coyote Timer if we allow the player to jump after they fall, right? We'll say if event.is action pressed, and we say it's jump. Okay, so if the player presses the jump key while we are falling, then we could just return the jump state. And obviously, I hope this is obvious. This will kind of work, right? But now we can jump. It doesn't matter how how far we are. Like if I run off this tall cliff, boing, I can still jump. Every time I'm falling, I can jump actually, which is funny. So what we want to do is we want to say if Coyote Timer is greater than 0, then we can try this. Okay. So then what'll happen is it's only going to let us jump if that Coyote time is above 0. And in order to really test this, let's go ahead and find my fall state. I'm going to set the Coyote time to half a second right now. So it's not too much, but it's a little bit easier to maybe see. Okay, so here we go. I should be able to jump after I've fallen off the edge, right? Boink. But I can't do that thing. Let's go over here to where it's a high. I can't do that thing where I could just keep jumping, right? I could, at one point there, I could jump, because half a second is actually kind of a long time. Let's go ahead and reset this Coyote timer to 0.125, which I think is an okay value. It's a little bit gracious, but it's still good for testing. So you could see that I'm running, boink, and even though I'm off the edge, I can still jump. And your Coyote timer, that time, you might want to reduce it even further so that it requires a more precise jump. But you can see what the effect of that is, and really that's an exercise to avoid frustration for the player, because that's an important thing in game design. You know, if you are pressing a button and it doesn't do what you expect, even though you feel like it should, that can feel really punishing, especially when it's just, you know, within a small fraction of a second and it's going to cost you the run or the level and a whole life or whatever, right? And so just consider and balance the importance of this with the feel of your game. Increasing the Coyote time above 0.125 wouldn't be something I would recommend. I think this is, again, a gracious and a somewhat high time, but maybe a good place to start and dial it back. Get some feedback from some friends. Okay. But there we go. We've built a complete jump and fall state system here with the Coyote time. We've got variable height jumps, some sound effects tied in, and seems to be working pretty smooth. So thank you for following along. I hope you're still continuing to learn from and enjoy this series. Drop a comment below if you've got a question or just to support me, and give the video a thumbs up, and subscribe if you haven't yet. I really appreciate the subscribers. I just recently hit 8,000 and hope to keep growing and keep providing. And I'll just put a shout out in the middle of this. I mean, I've got an action RPG series that may not be your cup of tea. It's very long running, 70 episodes, chock full of all sorts of features that we're building. And, you know, maybe a little bit disjointed at times in how I present it, because sometimes we break up features and don't come back to them, or I didn't come back to them for a couple months to add to them. But, you know, something there for you to dive into. Join my Discord community if you want to get help, or you want to add suggestions, or just join a community of people who are learning to make games just like you are. So, wow, that was a mouthful. But with all that said, we'll see you next time.